Today we're going to talk about stretching, compressing, and reflecting functions. This is continuing the transformations from before. Before we talked about translation, and those were when we add or subtracted, and it did different things when we did them inside the function versus outside the function. The same thing is true with stretching, compressing, and reflecting function, except now it's going to be with multiplication. So, these are the four questions that we're going to look at. What happens when we multiply outside, inside, or put a negative sign outside the entire function or inside the entire function? So we're going to start with some parent function. For this case, I'm going to use the parent function of absolute value of x. So the black is going to be the absolute value of x. And the red graph is g of x, which takes in f of x right now, but I'll be changing it over the course of the video. So the first thing that we're asked to look at is what's 2 times f of x. So if we take this and multiply 2 times f of x, then what happens is each y-coordinate is being multiplied by 2. Again, when anything happens outside the function, it's happening to the y-coordinates, not to the x-coordinates. So it's the y-coordinate is being multiplied by 2. It is being stretched vertically from the x-axis. So this is a vertical stretch from the x-axis. Now, if we instead put that inside, that will affect the x-coordinate, and it looks the same. But what's happening is it's compressing horizontally. Why do they look the same? Well, if we take a point here and shift it into the left, it will look the same as if we take a point here and shift it up. So for this particular function, it's not very easy to tell, and you should know that. The 2 times the absolute value of x is the same thing as absolute value of 2x. So in this case, it's a compression, a horizontal compression towards the y-axis. What happens if we instead make it negative? If we make it negative outside, what's going to happen? Well, it flips, it's being reflected over the x-axis. So this is a vertical reflection. Maybe I should just say reflection across the x-axis. So based on this pattern, x-axis, y-axis, x-axis, you should be able to guess that this will be a reflection across the y-axis. And if we do that, well, hopefully you recognize that if we put a negative inside the absolute value function, nothing will change. Which makes sense because this is an even function. If we have a point over here, it's the same thing over here. So reflecting across the x-axis doesn't do anything in this particular problem. Let's try this with a different function. So I have this parent function. You're not going to need to worry about this. I just made a piecewise function that's listed over here. It's linear at the beginning. Then it is a different version of linear. Then I believe this is a quadratic, and then this is logarithmic. It doesn't really matter. The point is that I'm going to do the same thing with these. The first thing is we multiplied by outside, and we said multiplying by outside stretches the y-coordinate away from the x-axis. And there, it's very obvious. The x-intercepts are staying the same, and all of the y-coordinates are being doubled. So you can see that so far this is matching with what we said before. Now with the previous one, it wasn't obvious how different it was when we put the 2 inside versus outside. But the 2 inside should affect the x-coordinates, and what we said was it would be a horizontal compression toward the y-axis. And that's what you see right here, that each of these points is being compressed toward the y-axis. So the point that used to be -5, 3 is now -2.5, 3. Um, the next question was what happens when we put a negative here. Um, that was pretty obvious that it reflects, but let's see the reflection. You should be able to guess that the reflection is going to be across the x-axis. And that's if we put the negative outside the function. And this will work no matter what the parent function is. And if we put it inside, before it didn't make a difference because we were dealing with absolute value, and absolute value flips over the y-axis, no change. But flipping this over the y-axis, you'll see that that's the new function. So hopefully this clarifies how each of these four transformations works. So let's say we have this point is on f of x, and g of x is a reflection across the y-axis. Which of these must be true? So what we should be able to say, you can do this just by using your reflection rules across the y-axis. But another way you can say this is, well, our reflection across the y-axis is changing the x-coordinates. It's saying that g of x is equal to f of negative x. When we put the negative sign inside, that's reflecting over the y-axis. So if we wanted to try these, we could say, okay, if I take f of negative 8, f of negative 8, we know that that's equal to negative 7. But we also know that f of negative 8 is going to be the same thing based on this rule as g of 8. So g of 8 equals negative 7. That's this choice. Thanks.